So these next three properties are the most important properties if you're going to be successful with logarithms. There's three of them. First, we have the product property, and it says if you have log base a of some base, and you have two things multiplied, you can break this apart or expand it and rewrite it as log base a of u plus log base a of v. And I remember that because multiplying makes things bigger, and so adding makes things bigger, so multiplying and adding go together. This also works in reverse. If you have two logs with the same base and they're added together, then you can go backwards and you can multiply the u and the v together. The quotient rule is very similar. Quotient means to divide. Divide makes things smaller, which means if you're dividing, you're really going to subtract. So if you're dividing two things, you really can subtract them. And you can also go backwards. If you two things subtracted, you can go back and divide them. And the last rule is the power rule, which means if you have log base a of u to some power n, you can take this n and drop it down in front and put it in front of the logarithm. So we're going to use those rules to do the next set of problems. So it says rewrite each logarithm in terms of ln of 2 and ln of 3. Well, to make 6, you have to multiply 2 and 3. So I can rewrite this as ln of 2 times 3, and because I'm multiplying, I'm going to really add, so ln of 2 plus ln of 3. And now I've done what I was told to do because it says rewrite each logarithm in terms of ln of 2 and ln of 3. Well, I did right there. Number 4, you're going to first break it apart. So ln of 2, you're dividing, so you're going to subtract ln of 27. I can't have 27, I can only have ln of 2 and ln of 3. So I can make 27 by doing 3 cubed. So I have ln of 2 minus ln of 3 cubed, and that power, I'm going to drop it in the front. So ln of 2 minus 3 ln of 3. I'm going to keep using these rules, and I'm going to work on the next page. So number 5 says find the exact value of each expression without using a calculator. So I'm going to rewrite this as log base 5 of 5 to the 1/3. And then I'm going to drop the power in the front, so I have 1/3 log base 5 of 5. And I'm going to look at this piece right here, the log base 5 of 5. Log base 5 of 5 is like saying 5 to some power equals 5. Well, that's 1. 5 to the first is 5. So log base 5 of 5 is 1. So really you have 1/3 times 1, which is just 1/3. Okay, number 6 says that I have ln of e to the 6 minus ln e to the 2nd. So 6 ln e minus 2 ln e. Well, you subtract 6 of these minus 2 of those, it makes 4 ln e. And then I'm going to use the same property that I used on number 5. I have 4, I'm going to rewrite ln as log base e of e, which is like saying e to what power makes e? Well, e to the first makes e, so I have 4 times 1, which makes 4. Okay, so now 7, 8, and 9 say to expand, which means you're going to take this nice, pretty little itty-bitty logarithm and make it nice and big. So what that means is I'm going to have to use all of my rules. So first of all, I'm multiplying all of those together, so I'm going to end up adding. So I'm going to have log base 4 of 5 plus log base 4 of x cubed plus log base 4 of 7, sorry, should be log base 4 of y. And then the last thing I can do to expand it is I'm going to drop the 3 in the front. So log base 4 of 5 plus 3 log base 4 of x plus log base 4 of y. Make sure that every time you write your log base 4s. Okay, number 8. Okay, so I am dividing, so I'm going to subtract. So I have ln square root 3x minus 5 minus ln of 7. I can rewrite the square root as the 1/2 power, so, and then I can drop the 1/2 in front. Make sure you note on number 8, I had to keep the parentheses the whole time because this 1/2 or the square root belongs to all of the 3x minus 5. So you have to keep parentheses around it so it stays together. Okay, so for this one, I really can rewrite this as ln of, on top I have x squared square rooted, and on the bottom I have y cubed square rooted. The square root of x squared is just x, so really you have ln of x over the square root of y cubed. I want to run out of room, so I'm going to go down here. And then since I'm dividing, I'm going to subtract, so ln of x minus ln of the square root of y cubed. And then I'm going to rewrite the square root as the 1/2 power, and then I can multiply these two powers and drop it in front. So I'm going to have ln of x minus 3 times 1/2 is 3/2, and I'm going to drop the 3/2 in front, ln of y. Okay, so for 10, 11, 12, 13, we're doing the opposite. Instead of making it nice and big, we're taking the big thing and making it small. So I'm going to put the 1/2 power up top. I'm going to put the 3 up top. So really I have log x to the 1/2 plus log x plus 1 to the 3rd. And since I'm adding, I'm really going to multiply them. So I have log, big parenthesis, x to the 1/2, x plus 1 to the 3rd, close parenthesis. You need to have parentheses on the outside too because it's log of the entire thing. Okay, so number 11, I'm going to put the 2 up top, and this x is going to go on the bottom because we're subtracting. So we're going to do this problem in one step. I'm going to have ln, I'm going to put a fraction bar, x plus 2 squared goes on top, and this little x goes on the bottom, and that's your final answer. Okay, 12, everyone on the inside has to get the 1/3 power, so I have 1/3 log base 2 of x plus 1/3 log base 2 of x plus 1. Since everything's to the 1/3 power, everything's going to be cube rooted, so what I really have is log base 2. These two get multiplied, and I have a cubed root, so it's going to be x plus 1. Okay, so on 13, I'm going to distribute the 4 first, so I have 4 ln z plus 4 ln z plus 5 minus 2 ln z minus 5. Let me rewrite that 2 so we know that it's a 2. Okay, everything with a plus sign, it goes on top in the fraction. Everything with a minus sign goes on the bottom. So I'm going to write my big ln out front. This 4 goes up top, so z to the 4th. This 4 goes up top and it's adding, so it becomes z plus 5 to the 4th on top. This is subtracted, so this z minus 5 squared goes on the bottom, and there's your final answer. So what you're going to do now is you're going to try the next page. You're going to do all of these problems, and then you're going to go back to Edmodo and look at the picture and see if you got them right.